Thank you. All right, let's move on to number 2 then. Given f of x equals x squared and g of x equals x minus 3, find find fg of x. So again, I need y'all to remember these definitions here. So fg of x, let me highlight it. Fg of x is just the product here. F of x times g of x. That's all it means. F of x times g of x. So let's write it out. Fg of x equals f of x times, so you can put a dot here, g of x. But when we go to the next line, we're going to put f of x down. What is f of x in this case?
X squared.
Yep, x squared. Should I put a dot or do I need to put something else to indicate
You put
multiplication?
parentheses.
Yes,
Parentheses.
please put parentheses in this case. Anytime you have more than one term, x minus 3, that's more than one term. That's two terms. We need to work on putting out parentheses. X minus 3. So that would mean I'm multiplying x squared times everything in the parentheses. So we distribute now. X squared times x.
X squared to
Yeah.
the third.
Uh, x to the,
Oh, that's 2x squared. No.
no, you just said it
X
wrong.
cubed. X cubed. Oh, Lord.
X
X
cubed.
cubed, yes. You put it all together. X cubed and then x squared times that would be what?
Minus 3x squared.
Negative 3x squared.
Minus 3x squared. Great. There's nothing else we can do with that part. But then it says, then, so we first found this, and then the second part of this question is, then evaluate. So again, evaluate means to find the value of, to find the value of. Evaluate the product. We just found the product. This is the product. Product in math indicates multiplication. That's all it, or implies multiplication. That's all that is. When x equals 4. So basically they want to know what is f of g of 4 equal to. How would you do that? Given that we already did some work here.
You sub in 4
Uh,
for
yeah.
All right, all right, good. Yep. So since we know that fg of x is this, all we're doing is replacing. Was that Nakir? Who said sub? Nakir, do you always say sub?
Yes, ma'am.
Yep, yep. Sub. See, I knew I wasn't even looking at the chat, and I knew who it was. Sub in this 4 in the place of x. So since I already know what f times g of x is, all I'm doing is replacing the x's with a 4. 4 cubed equals,
64.
all right, 64. Now this part right here, what are we supposed to do first? Here.
Work in parentheses.
Very good. So work the 4 squared first to get what?
16.
All right, so minus 3 times 16. So 64 minus 3 times 16 is
48.
48. And then 64 minus 48,
16.
16. Very nice. So that's how you would do number 2. Anytime you're evaluating, you are subbing, as Nakiria says. You're subbing or you're making a substitution to find. Normally, it's some value or some number. Normally is a number. It doesn't always have to be, but normally it is. Any questions about that one? All right. And I see here I said go to page 81 and complete number 8 and number 9. All right, so I'm going to go to mine because I don't have enough room right here. You might have to use your, use some paper, some extra paper off to the side. I am going to stop sharing this. And share the whiteboard. Ooh, okay. Number 8. F of x equals 3x plus 1. And g of x equals x squared minus 16. Let's first find out what f plus g of x equals. All right, what is the definition? What does it equal? According to our little box on the first page.
F of x plus g of x.
Yep, f of x plus g of x. And that makes sense. All right, if you look at it, it makes sense. F of x equals what?
3x plus 1.
All right, 3x plus 1. I believe that's Kenneth. Somebody other than Kenneth. Tell me, what do I write down for g of x?
X squared minus 16.
Nice. Can I do anything else to this?
No, you can just put it in descending order.
All right, we do want to put it in descending order. So where do we start?
You put x squared plus 3x.
And then what?
Oh, you got
Yeah.
1 and a negative 16.
What is that?
That's
Negative
minus 15.
Yep. All right, so we are done with that. F plus g of x equals x squared plus 3x minus 15. All
Dr.
right.
Thomas,
Yes.
I have a question. Is it number 8 and 9 on page 81?
Let me look. Are you looking at the textbook?
Yes, ma'am, because number 8 is a different one.
Oh yeah. See, I when I did these Semi-Guided notes, it was an older edition of the book.
Okay.
So it may not be the same anymore.
Okay, I'm just curious.
81, number 8. Oh yeah. Well, what number is this? X squared. Oh, it's number 10
It's number
now, huh?
10.
Oh, okay, yeah, this number 10 now. They added some extra problems, it looks like. So this is number 10 now. All right. Let me make that note on my Semi-Guided notes. All right, this number 10. Now I wonder what number 9. Number 9 is number 11. I see. All right. Thank you. All right, yeah, we changed the edition of this book maybe this year, so that's why as you can see, they kind of recycle the problems, but y'all see it's not much of a change. They just so you think you're getting a whole entirely new improved book, but honestly, textbook company is usually the same stuff. All right, same problems. All right, but in different order. All right, B, let's go with f minus g of x. Give me the definition of that.
F of x minus g of x.
Yep, f of x minus g of x. That makes sense. Equals. All right, f of x equals
3x plus 1.
3x plus 1. Then we are subtracting something. Someone other than Kendra tell me now what's crucial that we need to put next behind the minus.
Parentheses.
Parentheses. Parentheses. Why? Maybe that someone doesn't understand why we're doing it.
Because it's positive. And no. Yeah.
Why
So
we
what is
put a
that we
minus?
Oh,
distributed?
because
Because the signs want to change.
the F minus Z.
Because
And
it's
you want to
signs
keep
that.
it positive.
Well, why did we put? Why wasn't it necessary over here?
Because it
Because
was
you
already positive. I
The
think.
You gonna
plus
have
sign is not going to affect it, right? The plus sign is not going to affect the signs, correct? So it didn't matter. You could put parentheses if you wanted to, but it wasn't going to affect the outcome of the answer. All right. You must put parentheses here for g of x because we are subtracting all of g of x. We're not just subtracting x squared. We are subtracting x squared minus 16. So you need to indicate that by putting that parentheses. Then we distribute. What do we get when we distribute?
minus x squared plus 16.
Good. And then let's write it in descending order and finish it out.
Negative x squared plus 3x plus 17.
All right. Sounds great. Any questions about B? All right. Let's go to C. F g of x. Again, someone other than Kenneth and Alicia, what is the definition? What does it equal?
F of x times g of x.
Correct. F of x again is 3x plus 1. And g of x is x squared minus 16. What type of notation do I need so that it looks right? Can I just put a dot here and put x squared minus 16? Would that work?
uh-uh.
Then you have to add parentheses.
Yeah, you gotta put parentheses. Again, this is another example when you have to put parentheses around, in this case, both, or else you're not multiplying everything in f of x times everything in g of x. If you did not put those parentheses, for example, like that, you're only multiplying what's in the middle. So that's not right. We're multiplying the entire f of x times the entire g of x. All right? So whenever we are multiplying binomials together, we are what we call foiling. Let's multiply. What's 3x times x squared?
3x squared.
3.
3x
3x
squared.
cubed.
3x
All
cubed.
Yeah,
right,
that's
do this time. All right, 3x times negative 16.
negative 48 squared.
Negative 48
X, my bad.
x. All
Ahead of
right,
myself.
inside 1 times x squared.
X squared.
X squared.
X, yep, and 1 times negative 16.
Negative
Minus
16.
negative 16.
Yep, and so how would you rewrite it?
3x cubed plus x squared minus 48x minus 16.
Very nice. All right, let's try. If I wrote it like this, f slash g of x, what do you think that means?
F of x divided by g of x.
Divided. Yeah.
Yep, this is division, so you probably gonna see it look like that in the book, but that's the same thing as this, which is the same thing as f of x divided by g of x. So if you see a little forward slash, that's another way people indicate division, okay? So you won't get confused. F of x equals 3x plus 1 again, and g of x equals x squared minus 16. Can you simplify that in any way?
No.
Nope, I don't see it. Now Now you could factor the denominator, but will it cancel out with the numerator? No.
No.
Right. Just to ask though, just to make sure y'all on y'all toes. What are the factors of x squared minus 16?
X plus 2, X minus 2.
X
Plus
plus
X 4.
4.
4, right? X plus
negative
4.
4.
Yep, x plus 4 times x minus 4. But x plus 4, x minus 4 isn't in the numerator, so we're good. It doesn't cancel out. We have 3x plus 1, something totally different from x plus 4 and x minus 4. So you cannot simplify that any further. So that's the answer for part D. Now, what if I ask, what is the domain of the quotient? What am I referred to when I say quotient?
The answer basically.
Division problem.
Answer of which one? A, B, C, or D?
D.
D.
Right.
D.
Yep. Anytime we're talking about quotient, we're talking about division. So we're trying to find the domain of this answer. All right. So what are y'all? How can we figure out the domain of the answer?
You set the denominator to 0.
Very nice. So we set x squared minus 16 equals 0. We actually don't want it to equal 0, so we're trying to find which x values will make it 0. All right. Someone already told us the factors are x plus 4 and x minus 4, so we already did that. Then we set each factor to 0. And we get x equals negative 4 and x equals positive 4. So what's the domain, though?
All real numbers except negative 4 and 4.
Oh, nice. All real numbers. Alicia, did you say except?
Yes, ma'am.
That's exactly right. Except these two numbers that we just found. Not these two numbers. Is it precisely not those two numbers? Except x equals negative 4 or x equals 4. All right. If we had to put in set builder notation, probably look something like this. X cannot equal negative 4 or 4, something like that. What about interval notation? Is anyone brave enough to?
I try.
All right, let's go with it.
Okay, you're gonna put negative infinity to negative 4
Ooh, okay.
and a
You want
union.
parentheses or a bracket right there?
I'm gonna say a parentheses because I think he got no bracket because it was parentheses. Oh, okay. Then you gonna put
Yep.
the union sign,
All right.
and then you put negative 4 to 4,
No, okay.
another parentheses, and then you gonna put another union sign, and then you put 4 to negative infinity. I mean 4 to positive infinity.
Very impressive. Very impressive. All right. Well, why did we put a parenthesis here and not a bracket, somebody?
Because
It's not included.
Why isn't it included? Why, in layman's terms, why don't we want it to be included?
Because it equal to 0. If
we plug negative 4, yep. If we plug in, hold on. If we plug in negative 4 into this x right here, negative 4 squared, then that'll be 16 minus 16, which makes the denominator 0. We don't want it to be negative 4, so it's not included. So that's why we put a parenthesis and not a bracket. But very impressive with that interval notation you just did. So, all right, we're going to move on to number 11 now. Now that we know what number it really is, number 11. F of x equals x squared plus 6, and g of x equals square root of 1 minus x. A, f plus g of x, as we know, is f of x plus g of x, which equals what, someone other than Kenneth and Alicia?
X squared plus 6 plus
Mm-hmm.
square root of 1 minus x.
Yep, exactly, precisely. X squared plus 6, that's your f of x, and plus g of x is the square root of 1 minus x. Is can we, are there any like terms? I guess that's the question. Are there any like terms?
No.
Nope. Done. We are finished. So even sometimes it looks like, oh, this is gonna be hard. There's a radical involved. Actually, that's the easiest one right there. A. All right, let's go with f minus g of x equals f of x minus g of x. All right, someone other than Kenneth, Christina, and Alicia. What would f of x minus g of x equal?
X
X
squared
squared.
plus 6, and then parentheses. Well, would you use parentheses on that since it has the bracket?
This is the definition. Look at it. So x squared plus 6.
Then you put the parentheses, then the
Oh,
square
we're
root
not
of 1 minus
multiplying.
x.
Are we multiplying?
We're
All right. This is
subtracting.
the difference, right? This is the difference. All right. So minus, right? Minus square root of 1 minus x. You can't do anything else. Done. All right. A was the sum, right? B is the difference. We're just doing the same stuff over and over again. Product. Now that one is probably what you were thinking about. F of x times g of x. So in this case, what do we need so that we can write it properly? Or C.
Parentheses.
Yep. X squared plus 6 times another parenthesis maybe. It's not really necessary that you put a parenthesis on this radical because it's kind of obvious that you have to multiply x squared plus 6 times all of that. It goes together. So all of this under the radical kind of goes together. You can't break it apart. It's under the radical. Let me show you another way you probably will see it. You could distribute this as x squared times the square root of 1 minus x plus 6 times the square root of 1 minus x. That's just another version of the answer. You could distribute x squared and 6. I think that's the only way you could probably see it. Other than you could have the radical in the front, like so. Every time I say like so, I think of Tabitha Brown. Y'all, anybody know who the YouTube influencer Tabitha Brown is?
Yes, I do.
Yeah. Every time I say like so, I want to say like that. All right, moving on. D. F divided by g of x equals f of x divided by g of x. So you can write on the side below it, x squared plus 6 divided by the square root of 1 minus x. Still can't do anything with that. So actually, these are the simplest ones here, even though it had a radical involved. Now the challenge is, what is the domain of this? Does anyone know how we can figure this one out? Because this is different.
Set the denominator to greater than or equal to 0.
Okay. All right, we're on to something here. And anytime you have a radical, I normally say set what's under the radical to greater than or equal to 0. This time I'm going to alter it a little bit. Can anybody tell me what I'm going to alter just a little bit? But Merrick is on it. Okay. So normally we set what's under the radical to greater than or equal to 0, and then we solve. I'm going to alter this a little bit. Anybody can see what I might change slightly with that statement. All right, maybe you don't see it. All right, so since this is in the denominator, do I want it to equal 0?
No.
No.
No, I don't want to equal 0. So alteration. For this one, we're gonna set what's under the radical to greater than 0, not equal, because we don't want it to equal 0 in the denominator. All right.
Miss Thomas,
Uh-huh.
I'm kind of confused. What's the difference between how we usually would set it and then with the alteration that you just said?
All right. Well, let me erase this. All right. So normally we had, and actually we're not finished with that, and I went off to the domain, but normally we would have like a regular, what is the domain of the square root of 1 minus x? That's normally the question. So you do this. Set what's under the radical to greater than or equal 0. No problem, because the square root of 0 is fine in this case. If this was the square root of 0 in the denominator, though, that would be a problem because that's undefined. We don't want to make it the denominator 0. All right. In this case, this is not in the denominator. This is considered to be in the numerator because it's like over 1. You get what I'm saying? In the numerator,
Yes, ma'am.
we're fine. We just don't want zeros in the denominator. It just happened to be in the denominator here. I just realized we didn't really finish this. There's a rule. Anybody remember there's a rule that we can't have radicals in the denominator? I'm not sure if y'all remember this rule. All right. So for this right here, this right here, we got a radical here in the denominator. What you're supposed to do is get rid of it by rationalizing the denominator. Anybody remember something like that? Rationalize
Yes.
the denominator. What would we multiply it by to get rid of?
You'll have to multiply the numerator and denominator by the 1 minus x.
The square root of 1 minus x.
Yeah.
Very nice.
Yeah.
Square root of 1 minus x. Square root of 1 minus x. So it kind of just flips it. All right. So in the denominator now, what will we have in the denominator?
1 minus x.
Yep.
Square root will cancel out.
Yep. 1 minus x. And in the top, the radical ends up in the top now. Right. And you can put you don't have to put that first. You can put x squared plus 6 first. Radical 1 minus x. It kind of flips it. All right. So really, if you look at this, it's two things we have to consider. We got to consider this denominator again. We don't want that to be a 0 in the denominator. And we still got to consider this radical. We don't want negative numbers on that. We only want numbers that are greater than or equal to 0. So actually, we kind of got ahead of ourselves on that one. I got ahead of myself. All right, because we didn't get the radical out the denominator first. So let's look at this. All right, we don't want the denominator equal 0, so set denominator to 0. One minus x equals 0. Let's solve for x first. That's one piece. This is one part of it. First piece. Okay. How would you solve for x here?
Get it by itself.
Yeah, how would you get x by itself? What would you do?
Take away 1 on both sides.
Subtract 1. Okay. And then that's negative x equals what?
-1.
And then what would you do?
Divide -1 by both sides.
All right. Divide by -1 on both sides. And then what would you get?
X equals 1.
All right. We don't want x equals 1 because if we plugged it in right here, we'll get 0. That's a problem. All right. I'm gonna tell you what I would have done. I would have just added x to both sides. Y'all see what I mean?
Yeah, you want to add a negative.
Yeah, you would have avoided the dividing by negative or multiplying by negative or whatever. All right, so that's one part. All right, we're good with that piece. We don't want x to equal 1 because if we plugged it in here, that would be a problem. Let's take Merrick's suggestion when she says set second piece. Set what's y'all see is in the numerator now. Set what's under the radical to greater than or equal to 0. All right, what's under radical is 1 minus x. All right, 1 minus x is greater than or equal to 0. What would you do right now to get x by itself?
Subtract 1 again.
All right, I'm gonna leave you alone. Subtract 1, and then what happens? What would you
You
get?
get negative x is greater than or equal to a -1.
All right, now what?
And then divide -1 on
Mm-hmm.
both sides.
All right. What ends up happening
The
now?
sign don't change.
Okay. Okay. So Alicia, tell me what would you write down now? What
So
would you write?
since it's negative, it's going to change to less than or equal to 1.
Oh, well, I'm impressed. All right, because I don't know if y'all know, there's another rule in math that says if you have inequality and you divide, multiply, or divide by a negative number, your inequality flips. Anybody heard of that one other than Alicia? They have a lot of rules. And
Yes, I have.
y'all heard? Okay, good. We on the same page here. Okay, so we got two pieces we got to put together. Let's look at our number line. We don't want it to equal 1. All right, that's gonna be a problem. All right, I'm put an open circle there. But it's okay for it to be less than, can't be equal 1, but it can be less than 1. So all these numbers are okay. How do I write that in interval notation?
You have parentheses,
Yeah.
negative infinity,
Yep.
comma, 1.
1. Now it's gonna be a
Parentheses.
parenthesis or okay, parenthesis. Why not bracket?
The one is not included, right?
Yeah,
Right, the one is not included because if if I plugged in 1 here, it'll be 1 minus 1. That's gonna be an issue.
it can't equal 0.
Right. And we saying it gotta be less than 1. Why? What would happen if we plugged in 2? What's wrong with that? If we plugged in 2 for x, do y'all see the issue if we plugged in 2?
It'll be greater than 1.
But why is the issue if I plugged in 2 in any of this? Well, where's the issue? Because it's looking fine right here. One, if I plugged in 2, I'm okay with negative being in the denominator. Where's the issue?
Because it says that because it's,
You just don't want it to be 0.
But we're saying the domain is we can only plug in numbers that's in here. Why can't I plug in numbers outside of this? What's the problem? What do you see the issue? If I plug in 2 or 3, why is the issue in this?
because
I
negative
want to see.
1 is less than 1.
Negative 1 is less than 1. Negative 1 is less than 1.
Mm.
Yeah, I kind of sometimes I ask these questions. I want to make sure you really do understand why you're doing some of the things. All right, at least some of it. Okay, because if I plugged in 2 here, what's the problem?
It'd be a -1. Oh, you can't have a negative square.
Yeah, we can't have negatives on the radicals. Yeah, I remember that. We on. That's why we set it to greater than or equal to 0, because we only want positive numbers on the radicals. That's why we set it to greater than or equal to 0, because greater than 0 are numbers that are positive. Just keep looking at it. It'll some of the stuff will be like, oh, that makes sense. Okay. All right. We're gonna move on though. We're gonna move on. Let me just throw a question out here. What if I said, what is f plus g of -1? What would you do?
You will just plug in the -1 for the x and set those. So it'll be like 1 squared plus 6 plus square root 1 minus -1
Okay.
or plus 1.
All right. So you plugging into this,
Yes.
right? Okay, very good. -1 squared plus 6 plus 1 minus a -1. All right. What is -1 squared? You already said it, but what's -1 squared?
1.
1 plus 6 plus square root of, what is 1 minus a -1?
2.
2. So that's 7 plus radical 2. Can't do anything else to that. All right, good. I wanted to see if if we put something here, would you know what to do with it? You just, again, subbing, evaluating. That's all we're doing. All right. We're going to move on to composition of functions. I'm going to stop sharing this and move on our notes. All right, composition of functions. The definition of composition of two functions. The composition of the function f with the function g is this. So notice it's like a little circle. It's not fog, even though we want to call it fog. It's not fog. It's like a circle, not an O. All right. I usually say the composition of f and G. I'm not sure exactly how to say it, but I usually say the composition of F and G, or F of G of X. So this right here, F of G of X, that's normally what I say. All right, it says the domain of the composition of F of G is the set of all X in the domain of G, such that G of X is in the domain of F. All right, if it was written this way, for example, G, a little circle, F, this would mean G of F of X. So if G was first, this G would be the outside. If F is first, F would be the outside function. All right. And y'all see the inside functions will be second. Let me show you what it means when you're finding the composition. All right, let's look at A. Given f of x equals 2x plus 5 and g of x equals 4x squared plus 1, find the following. So I'm going to rewrite A. This means, again, f of g of x. All right, I need the proper color code now. Notice that the inside function is g of x. All right, we're going to write down the outside function. This one is f. The outside function is f, but we're going to replace the inside function. Replace the inside function with what is equal to. What is g of x equal to?
4x squared plus 1.
Yes, 4x squared plus 1. So all we're doing is subbing again, as Mercury says. We're making a substitution. We're dropping down what g of x equals. We're replacing g of x with what it's equal to, 4x squared plus 1. Then we need to think about, what does this mean? F of something. What are we supposed to be doing if we had f of something?
Multiplying.
F of something. F of something. So what we're supposed to be doing is evaluate the function f at 4x squared plus 1. Evaluate the function f at 4x squared plus 1. What does that mean?
That means you gotta put 4x squared plus 1. Well, no, you gotta put it where the x is in 2x plus 5.
Very good. Very good. Whenever you evaluate and you have something inside the parentheses, you are replacing the x with what's inside the parentheses. That will never change. All right. So he said we're going to take what f of x is equal to over here, 2x plus 5. If f of x equals 2x plus 5, then f of 4x squared plus 1 must equal 2 times what? Plus 5.
4x squared plus 1.
4x squared plus 1. So we're replacing the x in f of x with 4x squared plus 1. We're just evaluating, just like we've done for the last 3 weeks. All right, but we're going to clean it up a little bit. Let's distribute. So we have 2 times what's in the parentheses, which is what?
8x squared plus 2.
All right, then we're going to drop down our plus 5. All right, someone other than Kendall, what's the final answer?
8x squared plus 7.
All right, plus 7. All right, ask your questions now. Ask your questions if you have a question. All right. We're going to do B and C, and we're going to move on to something else. All right. Let's try B now. B is G of f of x. So that equals to G of f of x. What's the inside function this time?
2x plus 5.
2x plus 5.
All right. Or f of x. Yep. Y'all doing good. G of, you said 2x plus 5. All right. So now this is as saying evaluate the function G. Evaluate the function G at. Evaluate the function G at 2x plus 5. What does it mean, somebody other than Kenneth? I want to make sure at least somebody else can understand. What does it mean? What are we doing with this 2x plus 5?
4x squared.
I don't know how to explain it, but I know how to write it out.
Yeah.
You're going to
All right.
sub in 2x plus 5 into the 4x squared plus 1.
Into the what really of 4x squared plus 1? What are you
The
really
x.
substituting? Yes. So tell me what to write, somebody, exactly how you would write it.
So you'll put 4 parentheses 2x plus 5 parentheses squared plus 1.
Very nice. You got it. All right. And we're going to expand it or simplify it, multiply it out, however you want to say it. All right. So we're going to write down 4. What is 2x plus 5 squared? How do you
have to write it twice.
Very nice. That's what I wanted to hear. Please don't try to come up with a shortcut way to do that, because there is no shortcut way. All right, so that's 4 times. All right, I want y'all to multiply 2x plus 5 times 2x plus 5 and tell me what you get.
4x squared
Yep.
plus 10x.
Yep, plus 10x plus another
10x
10x, which is 20x
plus 25.
25. Very good. Then we're going to distribute this. 4 times everything we just wrote down, which is 16x squared plus 80x plus 100. Don't forget the plus 1, which is 16x squared plus 80x plus 101. All right. Any questions about B? Any questions about B? All right. Let's do C. C. If you go up here, this is what C is saying. What do you think we need to do with C?
Divide. Well, hold on. Not divide. Let's see.
Not divide. Because we're on composition now, so this is totally different.
Is you gonna substitute?
Yep, definitely substituting. Y'all see inside this parenthesis, this negative 1/2 is replacing what?
The x.
The x.
X.
Yeah.
Now we already did A, so technically a lot of our work was done, because isn't that what the composition of F and G is? We got this part. So for C, I'm gonna erase this on the side over here. Change color to something else. C, we got, so if F of G of X equals 8x squared plus 7, then F of G of X, -1/2, negative 1/2 will equal what?
It's gonna be 8, and then you're gonna
8.
sub in the -1/2 for the x, and then you're gonna square
Yep.
it plus 7.
Very nice. All right. So instead of an x, we're just gonna replace the x with -1/2 squared. So how would you do the algebra here? What would you do first?
When you multiply, then divide
Multiply what? What are we multiplying?
the 8 times 2 divided by 1. No.
We gotta use our please excuse
Square.
my Sally.
Oh,
Yep.
parentheses.
Gotta use this. We gotta go with this -1/2 squared first. So -1/2 squared, all that means is -1/2 times another -1/2. All that means is multiply the numerators and multiply the denominators. So what do we get?
1/4.
Yep, 1/4. Because -1 times -1 is +1. 2 times 2 is 4. All right. What about 8 times 1/4?
You simplified.
It simplifies to what?
2.
2. Because you really divide 4 into that 8 to give you 2. Then plus 7, which equals
9.
9.
9. All right. Very good. All right. Let's go with this last little piece here. Use the graphs of F and G, and then we're going to get probably last 10 minutes, get to something else. Use the graphs of F and G to evaluate the functions. Y'all notice we got two graphs. One is the F of X graph, and one is the G of X graph. All right. So I'm going to show you, you're going to do a lot of evaluating for these. For number 43. A, you have F plus G of 3. Can you give me what you think the definition of that is?
So you'll go and look at, I might be explaining it wrong, but I know how to get the answer.
Well, give
You'll
me the
go,
definition first. Let's not go too fast. Give me the definition.
It'd be F parentheses G parentheses 3, and then 2 close parentheses on the.
so would it be F of X
F,
plus G of X?
but we don't have X anymore. We have what?
Oh, 3.
So it'd be
F
F
of
of,
3 plus G of 3.
yes. So again, that used to be an X, but now it's 3. All right. So now we got to figure out what F of 3 equals. Which graph do you think we need to go to? The
The
first
first
graph
one.
or the second graph?
The first one.
The first one, because we are talking about F. So we are evaluating this function. Y'all are kind of good at this part. When X is 3, what is Y? So this is 3 right here.
2.
2 right here. Bam. So that's 2 plus G of 3. Should we be looking at the
1.
first graph or the second graph right now?
The second one.
The second graph. So when X is 3, what is Y?
1.
1. Very good. Again, you just evaluating. So the answer to this is 2 plus 1, which is
3.
3. All right. Let's just do all the A's. All right, 44A. F minus G of 1. Can someone tell me what you think that definition is other than Alicia? F minus G of 1.
F parentheses 1
Just say
minus
F of 1.
F of 1 minus G
Uh-huh.
of 1.
Yes. All right. Let's look at f of 1. We're going to go to the f function, the first graph over here. All we're asking is when x is 1, what is y?
Two.
When x is 2. 2. All right. Minus g of 1. Go to the g function over here. When x is 1, what is y?
1.
3.
3.
3, right? This is the point right here. 1, 3. All right. So 2 minus 3 is
Negative
-1.
one.
-1. All right, let's try number 45A. All of the other ones work the same way though. But I want y'all to write down the definition first before you try to look at the graphs. All right. What do you think this will equal to? This now it's not fault again. It's a little circle here, not an O. So what do you think the definition that goes here first before we look at the graph? So all you're doing is going back to these little, all you're doing is going back to that. So how would I write it?
You'll put L
F,
parentheses,
parentheses, yep,
F
G,
parentheses 2.
G. Somebody
G
said G.
Oh, G.
Uh-huh. Then,
parentheses.
uh-huh,
Would it be 2 parentheses?
correct. So instead of basically whatever the X was, you're just replacing it with a 2. All right. We wrote the definition out. Again, always write the outside function first and take care of the inside function. All right. So the inside function is g of 2. What is g of 2 equal to according to this second graph?
2.
2. So we're going to replace the g of 2 with a 2. What does f of 2 equal? What does f of 2 equal?
0.
Very good. You go to get to that 0, you go back to the f function. That's the first graph. And this point right here, 2, comma 0. So when x is 2, y is 0. All right, we're going to end that here. I think you have everything you need to complete 1.8 on Sunday. So I'll just
Okay, so this is section 1.8, right?
Yes, ma'am.
All right, section 1.8. What number is it again?
This is number 5.
Number 5. And D, you ended up with, let me look at your answer. The square root of x squared minus 16. Let me say this. How you wrote it in, the way I see it right now, your 2 minus 16, you got your minus 16 as an exponent. So you're going to have to arrow down when you put minus 16. But I'm going to show you what the
Yes.
answer is. Okay. It's not really the end of the answer. So square root of x squared. This is how you wrote it, like this in Weber sign, but it shouldn't be that way. All right.
Okay.
All right. But this is the same thing as this. It's supposed to be square root of x squared minus 16 over the square root of x plus 4, but that's not the simplest form. Let me explain why. Because
you can factor this, can you not factor?
Yeah, you can.
All right. All right. You can actually factor to the square root
It'll be
of what?
4 and -4.
So how would I write it? Tell me exactly what to write under this radical. What are
Would
the
you do
factors of
okay?
x
X,
squared minus 6? Mm-hmm.
so X, and then you would do +4,
Mm-hmm. And
and then
then
close out, and then
times.
X minus 4.
Yep. Very good.
X minus
And then
4.
that's over square root of x plus 4. Now there's a rule in algebra that says you can split up if you have something times something. For example, I don't know, 4. That's the same thing as 2 times 2, right? You
Yes,
can
ma'am.
even split that up even more. You can break it down as square root of 2 times square root of 2. All right, that's just an example. All right, this is the same thing as this. Square root of 4 is the same thing as square root of 2 times the square root of 2. Just let you know that. So following that rule, I can split up this as the square root of x plus 4 times the square root of x minus 4, like this, over the square root of x plus 4. So I basically split this radical
Okay, into two. Okay, two parts
to
of this
2
one.
radicals. Yes, to 2
Okay.
radicals. That way I can cancel out this and this. All right. So really what f divided by g of x is, it really is
Is
just square root of x minus 4. If you simplify it,
okay.
that's really the final answer right here. Now, you get that? This is the final answer.
Yeah, I
All
got.
right. All right. So that's all you need to put in the
So
web sign. That.
so
Now,
you
what is
do
the
have like the
domain?
x squared minus
Hmm.
okay, negative. Would it be all real numbers except -4? But in the interval notation, it will be negative infinity to -4.
Well, when you have a square root, all right, let me write this down. So you have a square root when you have even root, even root radicals, set what's under the radical, under radical to greater than or equal to 0. So it's not, this is not a denominator situation. So we don't set it equal 0. We set it greater than or equal to 0 because it's on a radical. Two different situations. This is a radical, square root of x minus 4, right? So the
So it
domain
will be
of square root of x minus 4. First, again, set this under the radical to greater than or equal to 0. Okay? And then
yes,
we will solve for x like that.
x
Then it'll be
plus
x
4
is
plus
greater
4.
than or equal to 4. All right. So if we look at a number line and we're like, how do I write this in interval notation? We're looking at everything that is equal to 4 and everything also that's greater than 4. Okay.
Oh, so it
So
will
how?
be 4
Mm-hmm.
to positive infinity. Okay. Close
Yes.
with the brackets though, right?
Yep. 4 to positive infinity. It's perfectly fine to have a 4 under the radical because the square root of 0 is 0. That's fine. We just don't want, if that radical was in the denominator though, we don't want it to equal 0 and it would have been a parenthesis if this ended up
Oh,
being in the denominator, the radical. But since it's not in the
gotcha.
denominator, it's like over 1. It's in the numerator right now. We're good. It can equal 0 under the radical. You get what I'm saying? But if it was like
Yes, ma'am.
this, if it was a radical in the denominator, then we would not want it to equal 4 here. It would have been a parenthesis 4. You get what I'm saying? To infinity.
Yes, ma'am. To
All right.
negative, yeah, to negative.
Yep.
Okay.
All right. So domain would be, and this is interval notation, like you said, bracket 4 to infinity. All right. Do you have any other questions?
Okay, yes, I do. I have, okay, I'm sorry. I have like, I need help on number 6. Not the domain, but just like because it's x over x plus 4, and then g of x equals x cubed. So do I have to get
All
rid of
right.
the x plus 4 at the bottom?
So, okay, let's see. F and G. All right. So number 6. Your f of x was
X
x
over
over
x plus
x plus 4. Okay. And g of x was
x cubed.
x cubed. So f of g over x is, again, f of x over g of x. All right. And then you, okay. So this means it's x over x plus 4, then over x cubed, right? All right. So this is
Yes, ma'am.
this is not in simplest form because we got too many division bars here. All right. So we got to basically do this. This is the same thing as x over x plus 4 divided by x cubed, correct? Aren't these the same? X over x plus
Yes,
4
ma'am.
divided by. And we know the rule when we have that little division symbol right here. Remember, if this is x
Is it
cubed over
keep
1,
flip?
yep, we keep, like you just said, change, flip. All right. So that's change to a multiplication symbol, and we have 1 over x cubed. So really what we have is x times 1, which is x, right?
Yes,
Oh,
ma'am.
wait a minute. No, we can reduce. I
Do
just
you
saw
cross
that.
multiply?
Mm-hmm. Look, we got an x here, so we can get rid of this cube and make it squared. You see that?
So just be x. Yes, ma'am.
So really,
So
so it's now 1. We cancel it out right at the top. So it's 1 times 1, which is 1. And then we got an x squared at the bottom, but we also have times x plus 4. All right, so that's our f divided by g of x. All right, next,
yeah.
domain of this. Well, we have a denominator, don't we? So since we have a
Yeah.
denominator, we don't have a radical. We set x squared times x plus 4 to equal 0 to figure out what we don't want to put in the domain. All right. It's already in factor form. Notice already in factored form, so there's no need to factor it. All right. So we set each factor to 0. So we're going to set x squared to 0 and solve for that. And we're going to set x plus 4 to 0 and solve for that. All right. All right. Let's look at x squared equals 0. Let's look at this one first. How do I get rid of this 2? I just want x. I don't want x squared. How do I get rid of the squared?
With a square root with it?
Yep. We do the square root both sides. All right. Normally we'll put plus minus, right? Normally.
Yes,
But since
ma'am.
it's just 0, 0 is neither positive or negative, so it's no point of putting plus minus here.
But if it was any other number, you would have two solutions just for this one. You get what I'm saying? But since 0 is
Yes,
neither
ma'am.
positive or negative, we don't have that. All right, this one, we subtract 4,
And we get
and we
negative
get
4.
x equals a negative 4. All right, so these are the two numbers, these are the two numbers that are not in the domain, that are not in domain. So we got to figure out how to write the domain then and exclude these two numbers. So let's look at a number line again. All right, we got 0 somewhere, we got negative 4 somewhere. We don't want these numbers in the domain, right? These are the two numbers we don't
Yes.
want. Everything else is all good. All right, everything else in between these two numbers, good. It's just 0
So
and negative 4. Mm-hmm.
would it be negative infinity to negative 4?
Mm-hmm. Bracket or
And then would it
parenthesis.
parentheses?
Yep.
And then would it be the U sign and then it would be 0 to positive infinity?
Hold up. Okay, let's look at you started
Oh,
here,
negative
negative
4 to
infinity.
0.
Negative 4 to 0. Then,
And then U, then 0 to positive infinity.
yep.
Okay.
Yep. You feeling good now? Feeling better? What else you
I
got?
feel way better. Okay, I just need one more, and it's number 16.
Okay. Number
And then the other ones
16.
I can go back because now I got a feel of the rest of them, so I can do those by myself.
All right. All right. I'm looking at your 16, so let me write it down. Number 16. All right. F of x equals 2x. And g of x equals x to the 4.
X.
All right. And we got to find compositions.
Mhm.
Fog. It's not really fog. It's a circle. Okay. But I must say that's the one we're doing right now. All right. So that means f of g of x. So make sure you know the definitions. That means f of g of x. All right. So I'm going to put the g of x in red so we can maybe color coding it will help. I don't know. I like color coding things. All right. Always write down what's first. F is first. But what goes inside? G of x, right?
Is it? Yes, ma'am. X to the 4th.
Yep.
So you
All
don't
right.
plug in the 2x with the F, right? It's just the
But
F,
now
not
we're
F of
getting there.
X.
Yeah, we're getting there now.
Okay.
We just did G of x and we finished with G of x, right? Now we have
Yes, ma'am.
F of x to the 4th. That's when we need to concentrate our attention to the F function. But what are we doing with it? We
Plugging it
got
in.
F, where are we plugging in x to the 4th? Where are we plugging it in at?
Right there where the F is at.
Tell me what to write. Let me make sure you see if you know. So
So where
equal
do you
what?
plug in the X to the 4 or the 2x?
I'm out. Anytime something is in parentheses next to F of something, you plugging it in somewhere. Where do you
Oh, you
plug it
plug it into
into?
the 2x, to the F of X.
Right. So what do I write next? Equals what? F
So
of
you
x to
do
the 4th
equals
equals.
2,
Mm-hmm.
2 parentheses X to the 4th.
Yeah. Parentheses is not necessary, but very good job. Parentheses is not
Okay.
necessary because this is multiplication. It's 2x to the 4, right? So 2 times x to the 4
Yes.
is 2x to the 4. So you don't have to write the parentheses in this case. Unless it's like a binomial, if it had 2 terms, 3 terms, and higher, yes, make sure you put that parenthesis every time. All right, it was just one term, x to the fourth, so you didn't. It wasn't necessary. All right, so we are done with that one. Let's go to just joking. It's not golf, but I'm saying it like that. All right, so G is
Can I
first.
walk you through this the B just to make
Mm-hmm.
sure I'm doing it right? Okay.
Yes.
Okay, so you would do G then F of X in the parentheses,
Mm-hmm.
right?
Yep.
And then so F of X equals 2X.
Mm-hmm.
So
So we
2X.
first write
And then
G, and then you put 2x in. All
so
right. What
then you
else?
would do you plug in the where the X is, you would do the 2 would be like 2x to the fourth again.
Tell me exactly what you would write down. I want a notation and everything. What would exactly what you write down first?
I would write down. So I need to plug in now. So I would do a 2, then I'll do parentheses x minus x to the fourth.
All right. What are we replacing? Tell me what we're replacing. We're replacing what with what?
G.
All right. So we are replacing this. We are plugging this
to
into what? We're
G.
plugging it. Yes. So how would you write it if we're plugging in that into G? Because this is the left side of
So it's just,
G already. This is the left side. I need the right side of G. All right. I need the right
so the
side.
right side would
This is the
be
left
x
side.
to
We
the
already
fourth.
got that. The right side is this. So what would I write since we got G of 2x? What would be the right side? See, up here is
The
G of
right side.
x equals x to the 4th. So what would be G of 2x? What would be the right side of G of 2x?
Uh, will be 2x to the fifth.
Here you were replacing something. What are we replacing? We're dropping in 2x in the place of what? Let me write it like this.
X to the fourth.
All right, so if G of x equals x to the 4, what is G of 2x equals to? I just replaced this x with 2x, so I'm replacing this x with 2x. You get it?
Yeah. Okay, so you just do like that then. So you don't add the
Yeah.
extra like the x. Okay, I was making
So
hard
that's
on myself for
2x
what
to
it
the
has to
4.
be.
Yeah. Yeah. I think Alicia said that. Yes, I'm overthinking it. Yep, y'all overthinking it
Yeah.
because it's the same thing y'all been doing. Y'all been subbing, as Nakira always say, subbing the whole time. You are replacing the x's with what's in the parentheses. That's all we're doing. Now we do have to clean this up a little bit because if it's 2x to the 4, then that means that's 2 to the 4 times x to the 4. And what's 2 to the 4? So you might need a calculator for that one. What's 2 times 2 times 2 times 2?
16.
So your answer is 16x to the 4
Fourth.
for that one.
Gotcha. So for the C, would I just do the G the G of X because like the GG.
Mm-hmm.
Okay, gotcha.
So it's G of GX. So see if you can work on it. All right quick,
Okay.
okay? I'm back. What did you say, Felicia?
I said, would it be okay? This is not the answer. This is why I'm plugging it. Will it be X to the fourth, then close parentheses, then the 4 at the top?
Okay, hold on. Me catch up to you. So let me get to the second
You're
step.
fine.
You put G, and then G of X was, what did we say G of X was?
X to the fourth.
Okay, yep, X to the 4. All right. So now we gotta basically plug that into itself. All right.
Mm-hmm.
So it's something to the 4. What are we plugging in? We plugging in x to the 4th again.
The X fourth.
So we gotta clean this up though. because we got two exponents. What do we do with these two exponents?
When you add them together, 4 plus 4?
It's not this. There's a difference. This is
Oh,
not equal to this. So this one you add. This one you do what?
subtract.
Multiply.
4. Oh, okay.
All right. X to the
So
4
with
to the 4 means x to the 4 times x to the 4 times x to the 4 times x to the 4. Get it? So when you add this,
yes.
you get 16. You get it? So the
Okay.
best thing to do is just multiply 4 times 4. So you don't have to write it all out like that every time.
Gotcha. Well, thank you so much. Now I feel way better now.
All right.